Let's talk today about complex numbers. An imaginary number is what we get when we try to take a square root of a negative number. Seems kind of weird, but things like electronics, air conditioning, things that we like in our everyday lives, they don't work unless we use imaginary numbers. So they're not just something we use to torture you with. If you are an electrical engineer or you take a circuits class, instead of I, sometimes they use J, but it means the same thing. So, important facts to remember, that I is the square root of negative 1. So if I square I get negative 1 as my answer. A plus BI is a standard form for a complex number. So this is the real number, and this is the complex part. And technically any number can be written as a complex number, but we don't have to, so we don't. We have the product rule for radicals. So if I have the square root of A times B, it's equal to the square root of A times the square root of B. And A minus BI is called the complex conjugate of A plus BI, meaning the numbers are the same, just the middle numbers are opposite. So let's simplify some of these. If I have the square root of negative 64, I'm going to go ahead and write this as the square root of negative 1 times the square root of 64. And then this, because of this right here, this becomes I times the square root of 64, and the square root of 64 is equal to 8. And typically, we write the 8 first, and then the I. Let's do the square root of negative 98, which is the square root of negative 1 times the square root of 98. So that becomes I times the square root of 98. And this, let's see, 98 is 2 times 49. So that's I times the square root of 2 times the square root of 49. So that would be I times the square root of 2 times 7, which equals 7I times the square root of 2. Now if you had this is not wrong, it's just a weird way to write it. Typically we have the number, the I, and then whatever's left over, the variable or the not the exponent, but the radical would be next. Alright, gross. Let's look at the square root of negative 243. It's really not gross, it's just going to maybe be a little bit more work, we'll see. So this is the same as the square root of negative 1 times the square root of 243. So let's look at 243. And 4, 5, 6, 7, 8, 9. So there are rules of division. You can look them up. So if you add up all parts of a number, so if I add 2 and 4 and 3, that's 4, 5, 6, 7, 8, 9. That number 9 can be divided by 3. So I know this whole entire number can be divided by 3. And this, in fact, is 3 times 81. So this goes to I times the square root of 3 times the square root of 81. So I times the square root of 3 times 9, or 9I root 3. All right. We're sticking together. Okay. So this is all kind of stuff I already told you. The square root of negative 1 is equal to I. I squared is equal to the square root of negative 1 squared, which is negative 1. And we're still finding, when we go ahead and find the square roots, we're still doing the principal square root. So we're going to do the positive part. Here's a complex number, so 5 is the real part, negative 2i is a complex part. And here is our formal definition. In algebra, you got to have an algebra and forward, so calculus, trigonometry, those classes, you kind of have to have the rule before you can do it. So this is the rule that says the complex number is in this form, where a is the real part and b is the imaginary part. So if b is equal to 0, then a is a real number. If a is equal to 0 and b is not equal to 0, it's a complex number and is called a pure imaginary number. Okay, let's look at these problems. So given an imaginary number, it's kind of what we were doing before. To express it in standard form, we're going to write the square root of negative a as a times the square root of negative 1. We're going to express negative 1 as I, and then write the square root of a times I in the simplest forms. So the square root of negative 9. And remember, like I said before, if you can do something in less steps than me, that's awesome. I'm just the teacher, so I have to. I'm going to go ahead and do it. I normally pull the negative 1 out first, but it doesn't matter. So this is square root of 9 times the square root of negative 1. Square root of 9 is 3, and the square root of negative 1 goes to I, so that gives me 3i. And then they asked for standard form, and remember standard form is a plus bi. So this would be oh, look what I did. Well, no, that's right. So that would be 0 plus 3i. Okay, now let's look at this guy. So the square root of negative 4 is negative 24 is square root of 24 times the square root of negative 1. That goes to I. And let's see, 24, 2 times 12, 2 times 6. So that 2 times 2 is 4. So this would be the square root of 4 times the square root of 6 times I. And that would give me 2 times the square root of, or let's write 2i times the square root of 6. And then in standard form, it would be 0 plus 2i root 6. Alright. So if we add complex numbers and subtracting complex numbers, we really just treat the I like a variable. That's really all that we need to worry about. And also, remember, anytime we subtract something, we're subtracting everything in these parentheses, so we have to distribute that negative. So I'm going to add the real parts here. So 3 plus 2 is equal to 5. And minus 4i and plus 5i gives me a positive 1i, or just I. Now this one's going to be a little more tricky because I have to go ahead and distribute. So I have minus 5 plus 7i plus 11 minus 2i. Combine like parts. So that's going to give me 6. And that gives me plus 5i. Alright, so this says subtract this from this. So since I'm subtracting this from this, I'm going to write the 3 minus 4i first, and then I subtract 2 plus 5i. I'm going to distribute that negative in. 3 minus 4i minus 2 minus 5i. That becomes 1, and that becomes minus 9i, and that's my answer. Whew. Fun stuff, right? So multiplying, we're going to do it just like we did before. We're going to use the distributive property. So we'll take this 4n, so that becomes 8 plus 10i. Except what's 4 times 5, not 10. That would be 20. So 8 plus 20i. Alright, so when we have two of these guys and we're multiplying them together, it's a binomial times a binomial, so we're going to use a FOIL method like we did before. The only extra part is that when we get to the i's and the I squares, we may have to reduce or simplify a little bit more. So, given two complex numbers, multiply to find the product, you can use the FOIL method. Remember, the I squared reverts to -1, and then group together the real terms and the imaginary terms. So remember, first, 4 times 2 is 8. Outer, that's -20i. The inner 2 gives me 6i, and the first, outer, inner, last. So that's, oh no, that's a negative. 15i squared. And we're just going to recall I squared equals -1. So 8, combine these two, so that gives me a -14i. And this becomes -15 times -1. 8 minus 14i plus 15. So that gives me 23 minus 14i. Alright, let's look at another one. 3 minus 4i times 2 plus 3i. I'm going to do my first two. Gives me 6. Outer 2, 9i. Inner 2, -8i. Last is a negative 12i squared. I'm going to combine these two, so 6 plus I minus 12, and I squared equals -1. So 6 plus I plus 12, which gives me 18 plus 1i, which we just write as I. Okay, so when a complex number is multiplied by its complex conjugate, remember the conjugate is the same numbers with the different middle sign, the result is a real number. When the complex number is added to its complex conjugate, the result is a real number. So let's find the complex conjugate of each number. So same numbers. This is a plus, so that's a negative. So this can be written as 0 minus 1/2 I, if you want to be technical. So the complex conjugate is the same numbers, different sign. You wouldn't get it wrong if you just wrote it like that. Alright, so let's find the complex conjugate of this one. So same numbers, different middle sign. Alright, write a division problem as a fraction. Oh, so when we're going to divide complex numbers, you're going to write the division problem as a fraction. You're going to determine the complex conjugate of the denominator. We're going to multiply the numerator and denominator of the fraction by the complex conjugate of the denominator and then simplify. And I did not give you a problem. Shame on me. So we're going to do 3 plus 4i divided by 8 minus 2i. Oh, here we go. So you can actually see what we're doing. So we're going to rewrite this as a fraction. 3 plus 4i over 8 minus 2i. So and then we're going to multiply the top and the bottom by the complex conjugate, so same numbers, different middle sign, and we're going to multiply the top and the bottom. So that gives me 8 times 3 is 24, first, outer, so that's plus 6i, inner, 36i plus 8i squared all over 8 squared minus 2i squared. Remember that from our earlier factoring and multiplying sections. So this becomes, that turns into -1. So this becomes 24. Add these two, and I get, oh, that should have been a 32. You're like, Amy, what's your problem? Problem is sometimes when I'm writing and I'm talking, I look at other numbers or I just make silly mistakes. So that should be 32i. So 6 plus 32 is 38. And then that becomes a -8 all over 64 minus 4 times I squared. Let's look at the top here. That's 16 plus 38i all over 64 minus 4 times -1. 16 plus 38 all over 64 plus 4. 16 plus 38 all over, oh, where'd my I go? There you go. All over 68. If you want to divide everything by 2 and make it more simple, you can do that as well. All right. I might have gotten my pages messed up. Well, that's okay. We can still work on these. So I did give you one. I just was missing a page. So let's go ahead and work on this one. We're going to divide 2 plus 5i divided by 4 minus I, and we're going to multiply top and bottom by the conjugate. And the first two, that gives me 8. Outer 2 gives me 2i, 20i, 5i squared. And this is 4 squared minus I squared. And this gives me 8 plus 22i. That becomes a -1. So -5 all over 16 minus -1. 8 minus 5 gives me 3 plus 22i. 16 plus 1, 3 plus 22i all over 17. Alright. So these guys, let's look at the powers of I because they're cyclic, okay, or cyclic, however you want to say it. So I to the first power is I squared is -1, I cubed is the same as I squared times I, which is -1 times I, or negative I to the fourth times I cubed times I will give me 1, and then I to the fifth will give me I, and as we keep going down, you'll see it'll go I -1, negative I, 1, I -1, negative I, 1, I, and it keeps going every 4 powers. Your book teaches us a slightly different way, but I prefer this way. I know that anytime I get a power of I squared equals -1, so I'm going to look at 35 and see how I can rewrite that. I can rewrite that as an even number plus 1. So, and 34 is 17 times 2 plus 1. So I can rewrite I to the 35th is I to the 34th plus I to the 1, or just I. And then I can rewrite I to the 34th as I squared to the 17th power plus I. Now your book wants you to divide by 4, and I just think that dividing by 4 is a lot to hold in your head. Dividing by 2 is just a little bit easier, especially if you're anxious. So I know that I squared equals -1 to the 17th power plus I. So if I take -1 to an odd power, it remains and that's not a plus, is it? It's a plus in your exponents, right? But it's a multiply. Shame on Amy. So that's -1 times I, or just -I. So I'm going to point my mistake out to you instead of pretending like I'm perfect. And so I was looking at this and I was like, oh, I'm fixing to get 1 plus I, or -1 plus I, and that's not right. I said it would be a power of I. So I stopped and I said, okay, what did I do wrong? And I said, oh, I was looking at this plus up here. I probably should have written it on the other part of the paper because I'm highly susceptible of, if I'm talking, I'll look at a number at a different part of the page and write it down. It's just something I do. I'm really old and I still do it if I'm distracted. So I went back and said, okay, what did I do wrong? And so I went, oh, I just let this influence what I wrote here, but I knew that it should have been a multiplication. So that was the this here. I was like, warning, something's getting ready to be wrong, and so that's when I stopped and I went back. Okay, let's look at one more. I to the 18th. I want to try to get it in some form of I squared, and so I know that I can rewrite this is I, so 18 divided by 2 is 9, so I can write this as I squared to the 9th power, and so this becomes -1 to the 9th power, or just 1. Or -1, excuse me. So here are different, I had a problem with my printer, so hopefully on your copy it'll all show up blue, but there's other videos here that help you with complex numbers.